All right, so we're going to start off looking at some different strategies, some different algorithms besides the standard North American one, to work with some of these bigger numbers and to really develop that number sense that I was talking about. And the first one is probably my personal favorite. It's called compensation. And the way compensation works is like this. So let's say I've got a number that is pretty close to being a really useful number. Sometimes this is called like a friendly number strategy. So I've got these numbers here. I've got 1998, so 1998 plus 26. And I'm saying to myself, man, if that was 2000, this would be such an easy question. And so the solution is we'll make it 1,000. Or sorry, 2000. So how am I going to do that? I'm going to add 2. And where am I going to get that 2 from? I'm going to take it from the 26, the other addend. And the way this works is, I mean, all this is going into the same answer that's going to be over here anyways. So it's all going to be jumbled together anyways to give me my final answer, my sum. So why not just take a little bit of this now instead of adding on the whole 26? I'm just going to take 2 of it, and then I'm going to add on the rest of the value after. I mean, you can think about it in like the classic sort of chocolate bar situation. I'm not sure who this kid is, but one kid's got 1,998 chocolate bars. The other kid's got 26. They're putting their collection together. Good move by this kid. And they want to see how much they have if they put it all together, right? So it's all together, right? It's all going together. So I've taken 2, and then I need to take 2 away. And that turns this into a 24. And again, this only works, and then it's obviously very easy to add up. I don't need to stack that or anything. And it all works because it's addition. Everything's going to end up together anyways. So let's kind of skip the middleman. Just for a comparison, if I stack those, like I did a million times as a kid, it's a lot harder. I mean, here's 2000 plus 24. It's 2024. It's so simple. Whereas here, I need to go, okay, so that's like 14. And then I carry the 1, which isn't a 1. And now I got 12, and I'm carrying 1s again. And now I've got 10. But wait, do I write 10? No, I can't write 10. I bring this 10. And now it's 2 10s, which again, it's not. It's 2000. And there we go. So, for me, this is much easier. A lot less steps, a lot less chances to make mistakes. I mean, I'm literally adding 2 and taking away 2. And then I'm adding 24 to 2000, which is not very complicated. I kind of chose a question that worked well for me for compensation, but still, a lot more steps here, chances to make mistakes, a lot more chances to just make simple mistakes. And if you've marked as much math as I have, you know that kids write 13 and they know it's 14, but they just put a 3 there and then the whole question's wrong. It all falls apart from there. So that's called compensation. Great strategy. It's my favorite. Some kids call it friendly number because you're trying to build one number into a really easy number, and then you just kind of throw on whatever's left. So that's a good example of compensation. Another one we're going to look at here is called decomposition. And decomposition is pretty cool because you're going to take numbers actually apart in a way that makes sense for you. So I'm going to decompose a couple numbers right now, and the numbers I'm looking at are going to be decomposed into place values. So I'm going to look at some numbers here. I'm going to go 270, and I'm going to add on 44. And so with decomposition, you're really looking at place value. So I'm going to take apart 270. I'm going to turn it into 200. I'm going to add on the 70. And then if this was another number, I'd add on the 1s as well. But it's not, so I don't need to. And I'm going to take apart the 40. And I'm going to take apart the 4. And then I just add up all those numbers kind of individually, or I can work at a place value level. So maybe I'll leave the 200 alone, and then the 70 and the 40, I'll put them together to make 110. And then I can throw the 4 on here. And I mean, you can kind of like, once you get pretty good with decomposition, you just throw the 4 onto the end there. But anyways, so now I got 310 plus a 4, and I'll just add them by steps here, but I end up with 314. So that's decomposition. Not a lot of kids use that, but you could. And it's really just similar. You're trying to make friendly numbers, but you're making them specifically by place value. So that's the difference for decomposition. Here's another one called splitting. Very similar. And again, you're looking for those numbers that you like. So let's say I've got 65 plus 25. And I kind of know I'm good with money maybe. So I see that 25 and I'm thinking about quarters. So I'm going to leave it and I say, well, that's like got two quarters in it, two 25s, which is 50. So I'm going to turn it into a 50 because I know that's going to give me 75. And then I just bring on the extra, which is the 15. And I get that 75 plus 15 because I was really thinking about money. And then I just can go ahead and add those up to get my 90. And that's a really handy strategy if there's numbers you like. Some kids like those quarters, those 25s. Other kids maybe, I taught a kid who liked working with sevens, which for me is like kind of the hardest number to work with. I try not to work with sevens, but she loved multiplying with sevens. So whatever works for you. So that's called splitting. Very similar to decomposition. The only difference is decomposition is really working with that place value, whereas splitting is kind of a number of your choice. And the kind of the last one I'm going to show you, this is a great one if you're not doing so well with your addition. And it's basically just kind of add on chunks of whatever. In this case, since these are numbers that exist in the tens, right, 40s and 20s, I'm going to jump by 10. So I'm going to start at 44. I'm not going to change it. And I'm just going to add on the tens first. So I'm going to imagine kind of jumping up to 54 and up to 64 because I'm adding on those two tens. And then I just need to add on the 7. And I can even, if I'm not great at this yet, I can just even count up literally by 7, So it goes 65, 66, 67, and on until I get to that 71. So that's my answer there. And so that's call it jumps of 10. And it works. You can jump by sort of by any value. So an okay strategy, but really these three are, for me, the best strategies for addition. And personally, I like compensation because you can kind of build whatever number you want, and then you work with kind of what's left over. So you're always looking to make one of those friendly numbers. And I mean, sometimes it's better to make the second addend a friendly number, but you use the numbers that work for you, which is why I really like this strategy. It doesn't force you to work with numbers you don't kind of like. So hopefully we can try some of those out and see what you think.